way in the back. So welcome to the first session for our summer school. Today's course, I will be going through an introduction to the bash command line. If you have any questions about the material, please feel free to use our Slido that's available here on the link, either via the QR code or on slido.com with the code ARCSS25. And I will be able to see the questions as they come in. I will probably answer them as we get to the exercises, and I take a pause for everyone to work through those. So as Rachel mentioned, I'm Jacob O'Shea. I'm the Senior Systems Analyst for ARC, and we'll be going through the basics of how to use the bash command line and scripting using the bash scripting language. As a prerequisite, we are going to be connecting to a remote machine that is set up for our use for the exercises. There are a couple different ways that you can go about this. If you're using Windows, Windows 11 and I believe 10 also now have the SSH client built into your command prompt. Another option that's available is to use the client MobaXterm, and I will be presenting from using Windows with the SSH client. If you are on a Linux or Mac machine, your base terminal application within your operating system should also be able to use SSH. And if you're on an Android or iOS device and following along, there is an application that I'd recommend, which is called Terminus. This allows you to make remote connections using SSH versus Android. I have not actually worked through using Terminus myself, but I did a basic check to make sure that it lines up, and it should work. If you're a remote participant, when we're using our remote connections, we have about 250 usernames available. And if you are connecting remotely, you can claim one of the usernames for your use at this link here for the tiny URL. This will take you to a Google Docs sheet that basically has the connection IP, the password, and then a big list of usernames. Please just place your name or initials next to one of the usernames to claim it for your use during the session. So that for everyone who's in the room, the slips are just the username that you'll be assigned. Yeah, the actual login information will be on the slides as well. So a brief overview of what I'm going to cover today. First, we're going to start out looking at how to use SSH and how do we connect to the remote system. Since we're going to be doing all of our exercises on a system that has been set up with kind of some prerequisite files, learning how to use SSH is going to be our first step, and then understanding the basic terminal commands. Oh, I can't actually, oh, and Zoom. Okay, what are they saying? Okay, I can try turning myself up some. Is that better for whoever's asking the question in Zoom? It also made the room a bit louder, but it's good? Okay. Yes, thank you for letting us know. If there's any audio issues, please let us know. Since this is being recorded, we want it to come through nice and clear for everyone. So just to start again here, what we're going to be starting with for this session is learning how to use SSH and the basics of what a command line is and why we would use one. And after that, we'll move into looking at how to manipulate files, either by browsing through the directories, moving them, copying them, or compress them into archives. After that, we'll get into doing actual text file manipulation using the simple command line text editor called Nano. And then we'll move into using environment variables and basically setting variables for your session for Bash and what some of the default ones that are set by the system itself and how we can export some of our own custom variables. After that, we'll have about a 10-minute break in the session, just for everyone to finish up exercises, use the washroom, get water, have a little bit of break, and we'll get back into the session with looking at how do we search through files or search files within the operating system using the grep and find commands. Then we'll talk about doing piping and redirection and how do we combine multiple statements together to do more complex tasks. And finally, we'll wrap it up with one last exercise on how do we make a Bash script and use all of the tools that we've gone over for this session to do a task. So for everyone present, if you're using Windows, you can access your command prompt using the Windows key and then type CMD, and that should bring up your command prompt. And you can connect to our remote session by using SSH, the user ID that's either on the slip of paper or that you claimed in the tinyURL page. And then connecting to ubc-summer-school.c3.ca. For anyone who's using MobaXterm, you would place the IP or the server name into your remote host and put your username in there. For everyone else, it's much the same with the SSH client. And I'll demonstrate here using my client myself. And then the password is available here on the slides or at the tinyURL page that's linked in the Slido. And when you've successfully logged in, you should have a command prompt with your username, login one, and then a $sign and a blinking cursor like that. So, Michael? Oh. Yes, if you have any issues connecting or using the password, either raise your hand virtually or please feel free to raise your hand in the Zoom room. I will put the slides up here with the password, so that way it's can be copied down from here. Yes. So if it says connection closed by for that one, okay. In that case, I would check your wireless connection or wired connection. And in that case, it might be that the connection might be unstable. For the other question that just came up, it will say something about the authenticity of the host can't be established. That is just basically for the first time that you log into a system, SSH will want you to verify that you know what you're connecting to. In that case, you can just type yes and hit enter, and it'll validate the key that it brings up. It didn't show up on mine because I connected in earlier to this session, unfortunately. So the password should work. I just copied it off of the tiny URL. I will put that up here. It should be pretty much identical to what's there. So if you're having issues with the password, I would go to the tiny URL link and you can copy it directly out of the field and paste that into the command line. One thing to note, when you paste it in or type it in, the cursor does not move. As part of the security for SSH, it will not show you typing the password and how many digits it is. Yeah. Also, I think if you're in Zoom, I've seen a few of the comments pop up there and you're having issues where it's still saying connection closed, try a couple times if you're, and see if you can connect. Sorry, I wasn't able to test every situation for trying to connect to the server beforehand. I'll give about 5 more minutes for people to try connecting in. Is everybody in the room here physically able to connect? Is there anybody that's still stuck trying to connect here? Oh, Roman, do you help out the gentleman back there? Okay, so now hopefully everybody's connected. If you're not, please either raise your hand or raise your hand in Zoom. We'll have somebody assist you. I'm going to be going through right now just the basics of what we're looking at here in the terminal interface. So as I mentioned, once you're logged in, you should have a command prompt that's being presented to you. And that command prompt will have a few pieces of information on it. The first one is your own username. And the username is basically what the system believes you are logged in as. In my case, I'm user 250. Anybody else's case will be the ID that you either claimed or entered in on the command line. Then there'll be an @ symbol, and then the name of a server. In this case, the server calls itself login01, and that's just an identifier for the node within its own network. Generally, this is a shortened version of what the actual full length is. So in our case, the address was ubc-summerschool.c3.ca. That entire address is an alias for what the server believes itself as is just login01. After that, there's a little tilde, and that is a special character that I'll talk about here, and it means your home directory, or basically your starting directory as your own user. And there'll be a $sign and then your blinking cursor. So that little chunk at the start will be at the start of every command that you enter. And we'll work through that and kind of use that command prompt for all of the rest of the session here. Now, a few things about using bash. As I mentioned, that tilde means your home directory. You can also type this out to basically represent your home directory anytime that you use a file path. So if you wanted to say something within your home, you could do tilde/ and then the name of either a file or a directory. And that would be your home directory and then that file or subdirectory within it. Another special character that bash will look for is the star symbol. And this symbol is a wildcard. So when bash looks to find either a file or a name to complete it, the wildcard basically says this could be anything that would fit within what you're looking for. So you can use that to either represent multiple files that all have maybe the same extension, or maybe just a part of a file path that you want it to fill in for you. And when we look through kind of some of the arguments and commands that we're going to work with today, there's a couple common ways to bring up the help page for those. One is to type -h after the command. Most commands -h will bring up a help text and basically say, here's all of the various options and arguments that you could use when utilizing this. The other option that will also be used a lot is if you type man space and then the command, that'll bring up the manual for the command itself and give you the descriptive of here's what the command is, what it does, all of the various arguments, and sometimes we'll have a few examples in it as well. Another thing that you can do when you are working with commands is maybe you start a command and it's running and is either taking too long or hanging, or you want to cancel it while it's doing the command. And to do that, you can type the special, basically do Control-C in the window. And unlike Windows, it won't do a copy. It'll basically tell the command, interrupt whatever you're doing, return back to the command prompt. So it's a way to cancel out of doing something if it decides to hang or is taking too long. A few other things we'll look at here are just like the basic interface itself. If you've typed a command out and you want to go back and either look at the command or reuse it, there's a couple ways that we can do this. You can either use the up arrow on your keyboard, and that will tell bash to basically walk backwards through the commands that you've entered and bring those up in the window until you either get to the one that you want to use or change, or you reach the end of the history. The second way that you can do this is if you type the history command, it'll give you the entire list of everything that you've typed out as a bash command and print that out to the screen with a number for each of those in order. I'll demonstrate that here briefly and just kind of walk through some of these. So in this case, I've logged in and done a few things before. So if I press the up arrow key on this, I can actually go backwards through some of my various commands that I've done before. Down will go backwards through the list back until you have an empty command. And if I type history, it will actually print every command that I've done back up to 1,000 commands before by default. So in this case, this will be every command that I did when I was walking through this session myself to make sure that everything works. This will be very useful, and I'll talk about it a bit more when we get later in the session on doing redirection, and maybe if you wanted to look through a very large history and find maybe a specific command that you'd typed before and you don't quite remember the syntax and you don't want to look through 1,000 lines of your history to try to find it. As I mentioned before, we have this tilde here, and it represents my home directory. So if our next session is going to be, or our next topic is going to be about moving around, and I'll use the tilde to basically represent, again, my home directory. So if I want to move back to my home directory, I can use the tilde. And just as an example, this is if I wanted to pull up the manual for history. Since history is a basic built-in part of bash, it'll actually give me a lot of different bash commands that are all kind of in this one single document. But it's just kind of an example of how you can pull up a information on a command using the manual. The last part here, and I would recommend not typing this in right now unless you want to try to reconnect, is if you type in exit. This will close out your current session, which includes any SSH connection that you're in, and take you back to your previous shell, or close out the program entirely if it is your main shell itself. It is useful to know because you would like to log out at some point, hopefully. But I just want to bring it up here as it's part of the basics for the terminal interface itself. So now we're going to move on to hopefully actually doing something with this. And before I get into this, I'll talk a little bit about why we might want to use a command line. In many cases right now, you're probably doing research and you're using maybe your local desktop and you're interfacing with it either through a graphical interface or working with software that has graphical buttons and such to connect with. When you're working with high performance computing or research computing in general, you may come across the need to use command line tools, whether to run, say, research software or to set up maybe large batches of work. If you have 1,000 files to run and do analysis with, if you have to click on a button that says run and then select the file and then do that 1,000 times, you're going to get really tired of doing that. One of the benefits of doing a command line is you can actually script things to do that automatically for you, where you run one script and it will basically walk through and do that action on that each individual time, one at a time, going through all those files, so you don't have to click through it. Yes. Yep. So I'll when I walk through using any of these commands, I'm going to bring up the bash screen after I talk about them and give a brief example for it. So one of the big benefits for the command line itself is when you're either working on a remote system that is doing a lot of work for you, or you just want to do a lot of work in order without having to click through everything, you can actually write commands in the command line to handle this. And understanding the basics of how to use a bash system, which is probably going to be the most common Linux interface that you will interface with on research computing in general. So moving into actually using some commands in bash, what we're going to look at here first is how do we list files in a directory? And for listing files, the simple command is just ls. And when you put in a command, you can also specify a number of arguments. And these are basically modifications to the basic function of ls to tell it either give me more information or list these files ordered by time or reverse the list of those. And that's actually the three arguments I listed here is -l gives the long listing, which is give me more information. -t says order everything that I'm listing by time. And -r says reverse the list. And I'm going to move into using the shell here. So in my case, I'm in my home directory. I would like to list all my files. So we can see here, I have a number of files in my home directory. They're color coded by bash automatically based off of their file extension and what they are. So in this case, the dark blue are directories, red are archives, purple is a image file, and the light blue is a symbolic link or like a shortcut. And this is just kind of the basic listing from ls. If I wanted more information, I could do ls -l. And this will actually give me all of those same files again, but also give me a lot more information. On the left, we actually have all of our file permissions for each file. So in this case, this file permission it notes it's a directory. The first three characters are for the owner of the file, which is myself. The next three are for the group that's a member of the file, and the last three are for everyone on the system. So in this case, this is a directory. I have full access to read and write to it and execute. And anyone who's in my group, which is just me, can read and execute it, and no one else can interact with this directory. Generally for directories, you will need to have the execute permission if you want to move into it, which I'll talk about for the next command. But as I mentioned some of the other ones here, we also have the time that it was modified. And that's listed here with July either 3rd or 6th, and then a time code. So if I wanted to list all of these, not only by the full listing, but order them by time rather than alphabetical, I can do this, and it will list the earliest file at the top. And then walk backwards all the way until the first one, which was on July 3rd. Now, if I want to combine all three of those commands and tell it, actually, I want the most recent at the bottom instead of the top, I can reverse the list. And now it will print starting with the earliest and then going all the way to the most recent at the bottom. Now, I haven't been actually giving it any information other than just ls and then the arguments. If you don't specify an actual path for it to look at, then it will assume just wherever you currently are in the system. So in this case, I'm in my home directory. But say I wanted to list what was in one of these directories within it without having to move into it. I could do ls -l, and then instead of assuming that it's just in my home directory, I can actually tell it, I would like to look in my home directory, but also move into, say, this directory originals. In this case, rather than listing just my home directory, it's now listing everything that is inside of that originals directory. So now that we know how to view what's in a directory and what's there, maybe we want to actually move to somewhere else on the system rather than just sitting in our home directory. It can be useful for either looking at things, making modifications to files, and basically changing where you're sitting relative to your other files. In this case, we'll use the command cd or change directory. So now instead of maybe wanting to sit within my home directory, I want to move into, say, my files. So if I do cd and then say files, now I can actually see, once again with ls, I have a different set of files because I'm within the files directory. And we also see that the tilde on the command line changed to say files. So rather than being at my home directory, it now is letting me know that I'm within the directory called files. And this can be used to move around. One thing that's really useful is if, say, I wanted to go, I went into a directory, and after I'd made some changes, I want to move back up to the previous directory above it. So in this case, if I do, yes. No, the order of arguments generally does not matter unless those arguments need additional information. I'll get into that when we start doing archiving, and the order does matter there a little bit. But for most commands, basic things that are arguments, you can list in any order. So if I wanted to move up to the directory before, I can do cd and then space and 2 periods. And this basically tells change directory, move to whatever the directory was that this is inside of. So I move up the directory and I end up back at my home again. And I can actually do this again and just walk up even farther. And now I'm in a directory that's called home. Home is actually a big system directory, and this has every user's home directory in it. So mine is there at the end as user 250. Each of your directories is also there. But because it's a shared system, if I wanted to, say, look into somebody's directory, maybe see what they're doing, if I tried to go and look at user, sure, 28. Yep. If I wanted to go to look at user 28, it'll actually tell me you can't do that. That's not your directory. You're not allowed to go and look inside of that directory. And this is important. If you're doing research work and you have files in the system that you're sharing with somebody else, you want to make sure that those file permissions are set up properly such that somebody else can't go and copy your research work and then publish it under their name. So by default on most systems, your home directory is set such that only you can access it. And it's important that you leave it that way because, again, if you put information in there, if you change it so that anybody can read it, that means anybody can read it. And that means anybody on the system can read it. And sometimes that's useful. Like when we're sharing information, maybe I want to share it with a group and I make it available for other members of my group, the directory. Or in our case, because we're going to be using some work out of the project directory, I want to make sure that everybody on the system can see it. Because it's publicly visible information, there's nothing sensitive that I'm worried about somebody copying. In my case, I want everybody to copy the files for this example. So after we've been able to move around, change directories and such, maybe we want to list, I've moved around in the system. I want to know where I actually am relative. Just a second. Thank you. Make sure to turn that one off. Okay, just apparently the batteries that were in my lapel mic died during the middle of me talking, so it turned off. Hopefully everyone can hear me again. I can hear myself echoing the room, so I think it should be going through. Yes, so if you're listing, you want to list your current directory, there's another command for that, and that's pwd or print working directory. So say I'm in the system and I want to know where I am. I can just type pwd and it will say I'm in /home. Well, what if I wanted to change and go back to my home directory? I can type in change and then the special character for my home directory. It'll take me back. And I can print again and do pwd. It'll say I'm at home/user250 because that's actually what my home is. So this is useful for knowing where you're at when you're changing around. It'll give you that bit of information and print it out to the screen. So now we've done all of our moving around, looking at where we're at. Maybe I actually want to make a change to the system itself. Yep. Yes, so there was a question on Slido of all I can see in my directory is projects in Scratch. You haven't added anything to your home directory yet. So what I have as an example is just things that I've put into it. We'll be adding files as we work through the examples and do things here. So in this case, everyone can actually kind of follow along with the next one, which is I want to make an empty directory. So I want to make something new. And the command for this is mkdir, or make directory. So I'm at my home directory, and I want to make something new. So we're going to do this and just call it new_directory. So it's returned, and now it's made that new directory. So if I do ls, we can actually see now we have this new directory that's listed here as what I've just created. Now if I do ls -l, we can actually see that it was created 1 minute ago by me. It doesn't have anything in it, but it has just been created. So if you're logged into the system, you can make your own directory this way, set it up. It'll give you somewhere that maybe you would want to put files in. So this is pretty simple. Again, we made a directory, but we don't have anything in it. Well, maybe somebody else has made a file for us, or we have a file somewhere that we want to place into that directory. So the time that's on the system, I believe, didn't actually get set up to be Vancouver. I think it's for UTC, so it is probably the time it is currently in England. A lot of times the system will get set up with the time zone that it's local to. In our case, this was just set up as a basic one. I don't think we configured the time zone with it. So I would not worry too much about the actual time that it's showing. You can just kind of understand that it being relative to the time zone that is set on the server. I can actually show a really short command here that's not on my slides. If you want to know what the time is on the server, you can type date and it'll say, it's Monday, July 7th at 5:14 p.m. But it does say UTC, meaning it's at the universal time in England. And that'll just give you what the current time is on the server itself. I don't have it in the slides because it's not really that useful outside of knowing what the time is currently. But now we'll look at copying a file. So if we want to copy a file and place it somewhere else, we're going to use the command cp or copy. And we give it two arguments. The first is the source file. The second is where do I want to place it. Additionally, I'll go through and give an example on how do we copy a directory. And in that case, when you copy a whole directory, you also need to give it the argument -r ahead of the source directory to tell it recursively grab everything from that directory and place it somewhere else. So in this case, I want to copy something into that new directory. So let's say I have this file here. So we have this PNG that I uploaded, this blue qubit, and I just want to copy it, and I want to place it in new directory. If I do that, and then I just list what's in the new directory, we can see it actually copied it. And the file itself is still here in my local directory. Well, if I want to copy a full set of directories, or a full directory rather than just a set of files, if I do copy and I don't give it that -r and I say files, and I want to copy that into my new directory, it's actually going to say, you didn't specify -r, it's going to skip copying a directory and not actually do the copy. So if I want to actually copy an entire directory, I need to do -r. And now if I go into that new directory, we can see it copied files, and it copied everything that was in files in there as well. And we can see now with printing my working directory, I'm in this new directory underneath the files I copied as a full path. So that's kind of the basics of how do I, move around, use files, look at files within a system. So what if I actually want to put my own files on the system? I have files, say, on my local file system, and I want to copy them to this remote server that I'm working on. In this case, we'll need to use the command scp. And scp is secure copy or shell copy, and that basically tells it, I want to move this local file to a remote location with the username, server, and then give it my full path of where I want to copy it to. I don't need everyone else to do this for the example. I just want to present it here because it's really important for wanting to actually upload your stuff to a system. So if I was to go back, excuse me. And I'm on my local Windows system here. Windows does have the scp command. This is also part of Bash and would be available there, but we want to copy from my local system up to our cluster. So I'm going to use the up arrow, which is also part of Windows shell. I'm going to say scp, and then a file here. We'll do that same one that I copied up before, blue qubit. Oops. I'm going to type it out rather than hitting tab. And then after that, we give it my username server, just like we logged in with SSH. And then I tell it, I want to place that file into a directory. I want to do home user 250. And then I want to call this something else. I'm going to call it new blue qubit.png. It's going to ask for my password. I'm going to copy it because I don't like trying to type that out one at a time while looking at it. and it'll say basically a little short thing there of it uploaded. If I go back to the window where I'm logged in, and I go back to my home directory, you can actually see now we also have this new blue qubit here, which is the one I just uploaded. So that would be how you would upload something using SCP from your local machine onto the system that you're working with. And the last part here before we get into our first exercise is we're going to look at how do we compress and how do we expand archives. So tar is the command in bash that will take multiple files and basically put it together, much as if you had a zip file or an archive on your local system. And we do that by basically specifying tar, CF, and then the name of our new archive that we're making. So that'll be the new archive.tar, and then we give it a file or a directory. So in this case, I would like to do a tar of my blue qubit, my new one that I just got. So I do CF new blue qubit. But this actually needs to be the tar that I'm making. So basically the file name that it's going to compress it into. Tar is a little odd in which you have to specify the name that you want to generate directly after the F. And then you list every file that you want to place into that archive. So in this case, I just want to do one. I'll just do that new blue qubit. So I'll run tar. And now we can see it's made this new qubit.tar. One thing to note is if you don't specify an option for compressing it, tar will just keep everything the same size and just wrap it into an archive. So let's make a few modifications here. Let's say I wanted to actually compress this and use zip compression. I add the Z here before the F. Yep. So CF, C is create archive, F is a file name for what you want to name that archive. And then Z is telling it to use zip for compressing that archive. So in this case, I'm going to do a new one, and I'm going to label this and just put GZ at the end. For compressing archives, archives usually are on Linux are .tar, and then they have, if they're compressed, they'll have an additional dot and a list for what was used to compress it. Since we're using zip, we put GZ at the end. GZ usually means gzip as the file format. And in this case, I actually want more than one file because compressing one file is all right, but it's an archive. I actually want a full list of things. So let's do both files, and I'll also look at grabbing my blue qubit. Yes. Yes, so .tar is just an identifier saying that this is a archive that was made by tar. In comparative to Windows and Mac, the file extensions in Linux don't actually matter. They're just part of the file name. But generally you want to, one, keep file extensions that are common on Windows and Mac, especially if you're using them. And two, it's a good way to identify what the file is, especially if there's software that is looking for specific file types. So listing it as .tar means it's like an archive that was made by tar. Yep. So generally, if you want to compress files with zip, it's something that you want to make an archive of and have it be smaller than the sum total of everything that's in the archive. Zip compression makes it smaller. It just takes a little bit of time and computational power to basically find a way to compress that into a smaller file size. Sometimes a lot of times that's really useful. Sometimes if you have millions of files and you don't want to take the computational time to compress each one of those, and they're all really small, maybe not using a zip compression would be beneficial there, because you don't want to wait 30 minutes for it to try to save 5% of the file size with zip. You just want to place all of those files into one archive that you can move and copy around. Sure. Yes, that's actually what I'm going to show right now. Is I'm going to tar this and just call it collection, and it'll actually put everything into that collection. We can actually kind of see it here. If we look at the size of the file, which is in bytes, that center like number that's right before the date is actually how big the file is in bytes. So in my case, the collection that I just made is actually about 60 kilobytes, which is both smaller than the qubit that I put in, and it also has everything that was in files. Everything in files is actually really small because it's all tiny text files, but it places it all together into that single archive. And I'll actually show that here, because I'm going to take that collection and now, sure, I've put everything into an archive. How do I get out all the stuff after I've archived it and I want to extract it? We're going to use tar again. In this case, instead of CF, we're going to do XZF. X means extract instead of create. Z means we're still using zip compression, in this case to extract everything because it was zipped up, so we're unzipping it. And then F says, where do we want to, what do we want to unzip and where are we placing it? So in this case, yes? So tar and tar.gz, tar is just an archive with no compression. Tar.gz as a file extension means you use tar and then compressed it down to be smaller with gzip. So in this case, I want to expand that archive. And we want to say, rather than just putting it back here because it'll just overwrite everything, let's copy that collection that I just had. And I'm going to put it in that new directory I made. So, oops. So we're in that new directory. We have our collection. And in this case, I want to expand it. So I'm going to do tar XZF for extract, unzip, and list the file that I want to expand. So I'm going to do collection. I expand it. That probably wasn't the best spot to put it because it just overwrote everything that I actually zipped up. And I'm realizing that now as I already had everything in that directory. So I'm just gonna make another directory. Okay, this directory doesn't have anything in it. So it actually makes more sense for me to extract it. So if I just up arrow here to where I extracted it, and I run that command again, now we can see it actually did extract everything that was in that collection and put it into this directory. I've made a lot of needless extra copies, but this is a good way to kind of show off everything. So I've been doing this, and some of you might have been following along, either doing a little bit of their own with making directories and such, but now we're actually going to do an exercise. So for this exercise, I want you to navigate to the directory on the system /project/summer/bash ex1. I want you to copy the most recent archive that's in that directory to your home directory. So by most recent, I mean modified most recently. And then I want you to navigate back to your home directory and then they extract the files from that archive into your home directory. And I will leave this up. After about 10 minutes, I'll walk through doing the same example myself. But please try to do it yourself. If you have any questions, raise your hand either on Zoom or in the room, and we'll be happy to help out. If you have any other questions, I'm going to pay attention to the Slido here. Please enter them there, and I'll try to answer them live or over text on Slido. All right. I'm glad this worked out. So it didn't work.
It just said,
Yeah, I was seeing some people that got that.
yeah.
That mentioned on Zoom. Okay, I'll have to try to move through this a little bit faster because I got an hour left. But I think we moved through a lot of this, the very basics early. Do it at the end, and basically we'll give out the swag. We'll have other stuff and reach out to them and say, "Hey, are you on campus? If so, stop by our office. We'll have something for you." We can give them something nicer than a lanyard. Oh, it just showed up. Okay. All right. So there was a question in Slido about navigating to the project directory. One thing to make sure is when you're using your change command, you make sure that you have that slash at the start of the project. So rather than just typing project/summer bash, do cd and then start with that slash for project. That starting slash is important. And it's a reason why I put it up on the list. You don't if it's going into the same directory that it's in. If you want to extract it to a directory other than where you're running the tar command from, you'll need to list a output directory afterwards. Generally, though, if you're extracting it, you probably want to extract it to where that tar is. That's why I'm asking you to copy it back to your home directory. Sure. Oh, yeah, that's the correct one. Yeah. So if you're trying to copy it off of the slides on OSF, those were uploaded before we had the full name for the server. So that unfortunately is going to be wrong. Please use the address that's listed on the slides available or off of the tinyURL page. The OSF slides are slightly out of date just because they were created before we had the server up and running.
Wondering about the remote transfer.
Mhm.
If I wanted to take something from a school computer
Yep.
and transfer it to my home, how do I find the address of my home computer?
Okay. So if you're moving files back off of a system, you can use SCP on your local system and connect to the school's one. And basically what you do is you reverse the order. So when I said local file and then remote system, if you put the remote system and then the list of the file first, and then where you want to place it on your local one, it'll do the copy and pull it from the remote or from your remote system and pull it back to your local one. Does that make sense? Okay. Yeah, of course.
I want to decompress to the new directory that I created.
Mhm.
But when I do this, it's not working. Is that something wrong here?
So if you want to place it into that one, what I would do is copy it into that new directory and then move it and extract it.
Is there a command for transferring?
Yes. Yeah, I didn't bring it up. It's just MV. MV is move. Yep. It removes it from where it was and puts it into the new spot.
At school, I use something called an SCP.
Yes.
Does that just do all of that?
It does the SCP command just under the hood. So it's very similar. Okay. Yeah, I'll answer them up here. Where'd Rowan go? All right. So there's a couple questions on Slido here I'll answer, and then I'll walk through doing the example myself. First one is an archive the same as directory? No, an archive is basically a single file. So it isn't actually a file rather than a directory that has multiple files wrapped up inside of it. Sometimes you'll compress it using gzip, but it's not an actual directory on itself. You can't walk into an archive and navigate through it as you would with a directory. So the other one was about a copy command. So the copy command that you have listed there would be right with one exception. You need to have your username after home. It's home, your username, and then projects, or just within your home directory itself instead of projects. So you'll need to put in user 340 or 034, sorry. So now I'm going to walk through doing this exercise myself. So if you either struggled or had issues with it or just want to see it done, I'll do it on screen here. So on your local system, you can technically place them anywhere you want. It's your local system. Again, they are just files that are a compression of multiple files. So if you want to copy them with SCP, they need to be somewhere that on your local system you can navigate to and then run SCP to push them to a remote system. So now that I'm going to walk through it here, I'm going to change directory to projects. Yep. Project. Summer 25. Bash EX1. And we can see I'm in this directory now, and there's archives here. I want the most recent one. I labeled them as which one's the most recent, but you know, I actually should probably look at that and make sure that that's the right time. So my most recent one here is not the one that was made last year. It was the one that was made a couple days ago. So I want to copy that. Bash summer 25. And I want to place it back in my home directory. So I say tilde for my home directory. Now, if I go back to my home directory, we can see I've copied that one. And if I do tar xzf bash, it's going to extract it. And we see I have this directory bash summer 25 that was extracted out of it. And if I go into it, I can see I have a number of files here, which are alphabetical ordered. Oops. There, now it says, welcome to ARC Summer School 25. So now that we've done our first exercise here on working through files, let's look at, maybe I want to actually go in and edit a file. So in this case, I have some text files that I just copied and were in that archive. Let's use Nano to go through and make some edits or view that file. So if I do Nano and look at this first one, just called welcome, we can see it opens up this command prompt text editor. And in here, we can just see there's some text in this file, and I can navigate my cursor around with the arrow keys. So if I wanted to add to this file, let's see. Oops. I can add text here. I can add enters. I can add anything that I want to this text file. And this will let me go through and just edit the text file. And then once I'm done, I need to write this out so I save the file. So along the bottom, there's a list of commands that are basically control keys that you can type in to do things within Nano that are more than just typing text. So in this case, the caret means control, and then the letter after it is what you want to type. In this, I would like to save it, so I want to write out the file. So Control O, and I'm going to write it back to welcome. And it says it wrote 5 lines. If I want to close out, I do Control X. And I don't want to save anything because I already did my write out to save. And I open it again. Everything has been changed in the file as I changed it. If I make a change and then exit and I don't save when I exit, I come back in, it didn't actually save that change. So we can use Nano. It's probably the easiest text editor. It doesn't have a lot of utility behind it. It has like cut and paste, some copy functions, find within it, but it's all very simplified. But if you're just getting started with using the command line, Nano is a really good tool for that because it has that simplicity, and all you really get is a text editor that you can navigate around, type text, and save in it. Yes. So from the Slido, there's most recent question, which is about Nano. If you use Nano to edit files, it must be set to executable. No, it doesn't need to be executable, but it does need to be writable. If you make an edit to the file with Nano and it's not writable, when you try to save it, it'll give you permission denied. And that means writable for your own user. If it's owned by somebody else and they made it writable for your group or for everyone, you can edit it. If not, then they're the owner of the file and they can, make it so you can't go in and add lines to something that they wrote without, them knowing about it. The other question that's on Slido, how do I know whether my server is a bash language or supports it? There's a norm for all servers nowadays to support bash commands and language. Generally, if the server is a Linux server, which I would say over 95% of the servers that you would utilize are going to be Linux, it will have bash installed. It is pretty much the most common shell, unless the Linux server is very old, at which point you probably won't be connecting to it remotely. Maybe if you have a server from early 2000s, it might not have bash, but any Linux server that is relatively modern will have bash installed on it. All right, so now that I'm done editing this file, we learned how to save it, we learned how to edit within it. Now let's learn a little bit about something called environment variables. And what these are is basically variables that you can set in bash that it will remember and have various functions. So I'll go over three simple environment variables that actually get set by the system themselves and what they have in it. So just like the pwd command, the $pwd is an environment variable that always has whatever your current working directory is. Sure. So there was a question just to walk through opening and saving with Nano again. So I'm going to go ahead and open, I'm going to open this Python file instead. So you just type Nano and then the name of the file that you want to look at. In this case, it's just a Python file. And a nice thing about bash is it knows a lot of various languages and knows how to color code for them. So since it knows that you're opening a Python file, it'll do context coding here in green, red, and blue that's relative to what you would expect to see inside of a Python file. If I want to make edits, I can just move through the file with my arrow keys and then type. And then when I want to save, I use Control O, and it says, where would I like to write this to? By default, it's the same file. If I just hit enter, it'll save it. And then Control X will close out of the file again. So for environment variables, there's a couple that are set by the system. PWD always has wherever your current working directory is. Path is a list of directories where if you type a command and it's in path, it will run that command and basically always search anywhere in path to run that. And then $user is your own username. So if you need to know what your username is on the system, you can use $user. And how we're going to look at these is using the command echo. Echo basically just says print whatever I tell it after this to the screen. And environment variables in Bash, you won't print the name of the environment variable. It will always print whatever is in the environment variable itself. So in this case, if I wanted to just go ahead and I will do echo, I do $PWD. Just like the PWD command, it'll tell me where I am. If I look at user, it'll tell me what my username is. If I want to combine this with something, again, echo will print whatever I tell it to. In this case, it'll just, if I do something, if I say instead username and then tell it user, it'll print out username : and then my username. So this is really useful for doing scripts later on. Yes, the environment variables do not technically need to be in all caps. It's generally by convention that you should use them in all caps, just so that it's easier to remember the name. They would be case sensitive otherwise. So like if I do like this, there isn't anything for user. The system ones all will be set in all caps. And generally, if you're setting environment variable names, by convention, you should probably use all caps as well. So now we want to set our own. In this case, what we want to do is we want to save our own environment variable for the session that we're in. And what we'll use to do that is the export command. And we do export the name that we want to have for our environment variable equals, and then whatever we want to set it to. So in this case, I would like to do export and if now I do echo, and we need the $sign to tell me what's in that environment variable. It'll say, you set up my home as home user 250. Now, you can put whatever you want in here. You can put a text string, you can put numbers, whatever you want to type in between the quotes, you can save it into the environment variable. And depending on how you parse it with software or commands, varies. So I did mention there's the system one for path. This one's a bit longer. This one actually has a number of directories and separates them all with a colon. Now, this doesn't generally mean anything to you reading it, other than knowing how to parse it. But to the system, it says, everything that's in $path, it will look in each of these directories to try to find something to execute when you type a command. So each of those directories, it will try to find it. So like when I type ls, it will actually look for ls in one of these listed directories. But we can use them within commands itself. So say I want to do I'm not in my home, if I wanted to, rather than typing tilde, because I want to type more information, I want to type more words, maybe I want to actually list what's in my home. So since I set my home as, again, my home, I can do ls, and it'll actually, print out what was in my home at home user 250. And you can use environment variables in any number of commands this way. And it's a good way to, when we get into working with scripting, if you want to set up something that you're going to repeatedly use in text, or something that you would like to easily change without editing it in 50 lines of text repeatedly, you can set an environment variable, edit it once, and then use the environment variable everywhere else. So they're useful for that. We have a very short exercise. You're basically just going to do what I just did here. I would like you to export a new variable for yourself called mytxt and set it to the path of, it was going to be a text file that you made, if you made one with Nano, or you can set it to a path of any file in the system. This is just to get familiar with setting your own environment variables using export. And then after this, we're going to have about a 10-minute break just for everybody to have a chance to use washroom, get water, refills, short break, and then we'll get back into things. Yes, so there is a way to print every environment variable that is set on the system. There's a lot of them that are set by the system itself, but if you're interested in every environment variable, you can do this command print env. And it's going to give you a lot of information because there's a lot of environment variables that are set even by default. And most of these are all ones that are set by system or software on it. So since the system has Slurm, it sets the Slurm one. This ls colors is a special thing for handling all of the various colors within Bash when you do ls. And there's a number of other bits of information here, like your SSH connection. Here's the variable that I just set for my home. And a number of other ones. But you can use print env, it'll list everything, which it could be a lot of text to search through. It's why I didn't go over it in the example itself. Yep. So basically, once you're finished with the session, we'll have a 10-minute break here. We'll reconvene at 11:10, and then we'll get back into working through everything here. And I realize the session ends at 11:30, so I'm going to try to go through the last bit somewhat quickly. Sure. Yes, so your environment variables get reset when the system reboots or you log out and log back in again. I muted it on here, but like it died.
Testing.
Okay. Yep. It's permanent. So there was a question on Zoom about how we can make environment variables permanent. So I'll explain that before we get right back into our text. So when you set environment variables, they only last as long as you're logged in session. Or in scripts, as we get into later, they'll last as long as the script is running. When the script finishes, the environment variable disappears. If you want something that will last longer, say after you log out and then when you log back in again, you can actually, there is a file that is hidden, but it is there for you to set. So if you go to your home directory, you do nano.bash profile, this is a little bash script that runs every time that you log in. So in here, I would want to say export my var So .bash profile will run every time you log in. So if you set an export here for an environment variable, it will always set itself up immediately whenever you log in. So it effectively persists between sessions by the fact that it gets added back in every time that you log back in. Now, if you edit that, make sure that you know that you edited it, because again, it won't tell you that it set it, it just will set it when you log in. So that it is something to pay attention to. If you're editing your bash profile, know what you've set into it, especially if things start acting odd. If you forgot that you set something and you try to maybe use an environment variable, or you, particularly if you change your path, I would not recommend changing your path unless you 100% know what you're adding to it in your bash profile, because if you accidentally delete your path, you might not have basic commands like ls and such because they're no longer in your path. So we have about 20 minutes left, so I'm going to try to go through these last 3 slides and give the final exercise before we wrap up here. The slides are fairly short, so I will go through them here and just kind of show a couple things you can do with them. So the first one is, how do we actually find files? So maybe I have a lot of directories and such, and I want to find something that has a name of a file that I'm looking for. Well, we have the find command. So what we can do is we can say find, and then we do dot. Dot means start looking where I am right now. So since I'm in my home directory, I'm going to start looking in my home directory. And then I say dash name, and this means I'm going to search by name. And I want to look for every file that ends in .txt. And this is basically saying, again, that wildcard I mentioned at the start, we want to put that here, find something with, it doesn't matter what the name is, and then ends in .txt. If I do this, it's going to print out from my home directory every file that ends in .txt in every subdirectory, and it'll walk through all of those. This was very quick. If you have thousands of files inside of thousands of directories, it will walk through every one of those if you don't give it a more direct specification. And that can take a lot of time. And if you didn't intend to do that, that's a good example of where you would use Control-C to stop it and then change the command. In addition here, we can also look for things other than just the name. We can use -user and a username to find who the owner is of a file. So in my case, I'm the owner of all my files. It's not going to be that interesting to search for. But I can search for files that also have maybe permissions. So if I want to look for a permission and look for something that has an execute permission on the group, I can use -g plus x after -perm. So we'll do that. If I do perm -g plus x, we can see here's all of the files that have a group execute permission. And if I look for O means other, so everyone else, we can see it's pretty much the same there. User will have a few more along those lines. So this is a good way if you want to like look to make sure maybe you'd set permissions for some of the files, but not all the ones. You can use this to look to list everything that's under, say, a specific permission. So this is a good way to look through the names of files and files on the system. What if we want to look inside of files? Well, there's a good tool for this looking at text files, and that is grep or grep. And you use grep, the string that you want to look for within a file, and then the file name. So let's go ahead and see here. I got those files from my bash summer 25. And let's go ahead and say grep the and from welcome. If we look at, oops, we can see I didn't use the word the here anywhere. And it is case sensitive, but now if I want to do it and say, okay, I've added this line. If I wanted to actually print out something, let's look for the word added. And it says, ah, yes, it is in there. Here's the line within that file where the word added exists. So it knows that it's in there, but it will only print just that one line. There are additional arguments that you can add to grep to add either more lines above and below every search or more options. And if you're interested in looking into grep, I highly recommend using man grep. And this is several pages. So I do not have the time to go through all of the many details that are within grep as to how it can search. But I would invite you to look into it and how you can use it for your applications. Our next little session here, we're good on questions? Our next section here is on piping and redirection. So in this case, we're going to look at the three symbols where the pipe or the vertical bar, and then the left and the right arrow or caret. And the first one is piping, and that is a way that you can take output from one command and pass it into another command as the input. So my simple example here is if I do ls pipe grep and then a string, foo is not a great string, but it's an example. I can do, so if I do ls minus l, maybe I have a lot of files. Maybe I just want to do ls minus l, and I just want to list everything that has grep txt. Now instead of listing everything, it'll list and say, oh, here's everything that just has txt. So you can pipe the output from one command into another to basically give it an input file. I mentioned this early on, this is actually really handy of maybe I typed a command, I don't remember everything about it, but in my history, if I want to pipe that and put it into grep, and I'm going to search for every time that I use the copy command. Well, rather than having to look through up to 300 lines of text to find it, I can look at every copy command. So this is a great way to look through your history and kind of parse it down to something that's easier to read. The next way that we can do redirection is using either input or output. This is really common for using with files. So if I want to take all the output from ls-l and print it into a file listing, I use the right-facing caret, and it basically says take everything from ls-l, everything that would be printed out to the screen, instead put it inside of file listing.txt. So if I do ls-l, and then redirect it and say file listing.txt, you can see it actually didn't print anything out like it did before. Instead, what it did is it made this file listing.txt, which is just what it would have printed to the screen. So this is useful and really common, especially if you're using command line software for research. If it prints a lot of information to the screen as a log, and you want it to actually save that rather than just print it to the screen, you can tell it, run your command, print the logs and tell it, go to this file instead of just dumping it onto the screen. Because the software might run for 5 hours, and you're not going to sit there, hopefully, for 5 hours watching it print lines of text on the screen. You want it to run, and then you'll look at the log afterwards and make sure that it did everything that it was supposed to. The reverse works as well. So instead, I can do grep, and I want to look for txt again. And instead, if I do the other direction with the caret, I can tell it, okay, take my file and actually put it into grep as the input. So in this case, it's going to read everything from that file listing and then use grep to search for it and look for anything that has txt. Yes. Yes, so it basically will take the output from one and put it into the next one with a pipe. The order in which they are listed in the pipe does matter, and some software takes piped in input better than others. grep is a really good one to use for pipes because it basically just looks for stuff that's printed in a text, and that's usually what you're getting for output from a command. I could probably go on for like 2 or 3 hours on ways that you can use piping creatively, but we don't have time, unfortunately, for that. So the last thing that we're going to go over is we've done all these commands. That's great when I want to type them into the command line. What if I want to write something that does all this for me? What if I just want to make a script? And what we can do in Bash is create a Bash script where it basically lists every command that I want to run, and then you just run that one file and it will do it for you. So what we're going to do is use Bash scripting to start it off. You tell it, I want to run a Bash file. So the very first thing you put in the file So apparently my lapel mic died a second time within 2 hours. So the batteries in these are not very good. But yes, so when you're starting off writing a Bash script in a text file, you start with the shebang, which starts with basically sh and then exclamation point bin bash. And that tells the system what shell to use it. since we're doing bash scripting, we want it to run off of bin bash. And then you could put commands within the script, basically anything that we've done today. And it will run within the script itself when you call it to execute. If you want to put comments in the code for the script, you can use lines starting with the hashtag symbol will be ignored. Anything that's after the hashtag symbol for that single line won't be parsed by bash itself. And after we finish up, we save the file and we want to make sure that it is executable. If the file is not executable, when you try to run it, it'll give you a permission error. So I'm going to go through doing all of this here as an example, and then I'm going to give you kind of a final exercise to wrap up with. Unfortunately, there's not going to be a lot of time. I'm going to place the solution also in the projects directory for anyone to copy. So what we'll do is we'll do nano and we'll make a script. I'm going to start with bin bash. I'm just going to do echo hello and do ls minus l. And I'll add, this will be a very basic script. It doesn't do much other than say the word hello and then list everything in the directory and then has a comment in it. But once I write it out, we can see it created it. But if I call it with dot slash and then my script name, it's actually going to say permission denied. And that's because I never make it executable. So the chmod command, if I do +x, now we can see if we list it again, it actually has that execute bit set. So anybody can execute this now. So now if I run it, it's going to say hello and then print out ls minus l. So that is like the very basics of how we can do a bash script. And again, you could place any of the commands that we went over today, whether it's tarring a file, moving directories and such, all that can be done within the script itself. And what we have for our final exercise is I'd like you to produce a script that does the following 6 things. It sets an environment variable within the script of script version to 1.0. It prints all the contents of the directory project summer 25 ex3 files and writes that into a file in your home directory. You copy the entire directory to your home directory. Then you use tar to compress the list of files that you made plus all of those files that you copied and make one tar gzip file. And then we're going to search through the copied directory of files for anything that has the user execute permission, so u plus x. And then finally, you just print to the screen the phrase script version : space and use the environment variable that you set at the top and the word done to the screen. So this seems like a lot, but it really is all quite simple of things that we've worked through. I'm going to go ahead and copy my solution to the project directory, and it'll just be in a directory called solution. But I invite you to try to do this yourself. And I will, since we're almost out of time, I will put up the final bit here of our survey. And I'll leave this up, but I don't know if there's a way I can leave the instructions up as well at the same time. So what I'll do is I'm going to copy that first here. I actually made this ahead of time. I'm going to see I have this final exercise, and I'm going to do CP minus R solution to project summer 5. I'll make sure that everybody can see it. Oh, I was muted?
On some.
That's weird. When did that get muted? Oh,
Now it's
okay. I'm sorry. I think how long was I muted for? Okay. Okay. So the last question was, is there a difference between calling / the script name and calling bash space the script name? Bash space the script name basically tells it I'm going to use bash to interpret this file. / will default to using whatever is in the shebang at the top of the file list. Okay, so chmod, I kind of went through that pretty quickly. Chmod is basically a way to change permissions on a file that you own. So doing that chmod plus X means I want to add the execute permission to my script so that it can actually be run by doing /. I could. I don't know how interesting it would be. The solution is available if you'd like to look through the script. I want to have a chance to put up the survey response form for everybody. If you would stick around for, say, maybe 10 minutes afterwards, I will walk through doing the script and basically what is in it. We are out of time at the moment, so I don't have time to walk through it live. Yep. So the solution, if you're in your home directory, you can just do copy project summer 25 and solution. If you copy this to your home directory, just tell it copy to my home. I can go into solution and then do nano final exercise. And this is actually the solution to it. So I'm going to put it up for a very short amount of time and I'll just close. But what I'll do now is I will go back here and we'll put up the survey so that everybody has a chance to get the link to the survey before they head out. And in 5 minutes, I'll switch over and I'll walk through the solution. Are we still recording? Okay. Let's just start recording on my end. Sure. So the recording afterwards will also have me walking through everything. We're just out of time at the moment. So I can't walk through it before giving the survey and letting anyone who wants to head off. So. So what I've done for the server itself, so we set up the server with a bunch of user accounts, all with the same password, and basically made it so that anybody can SSH and connect to it from any remote connection anywhere. This isn't exactly the best practice for especially something that you want secure, since we're just doing a demonstration here of just how to use Bash. It's a little insecure, but it is simple enough for us to set up so that everybody can access it without needing a lot of extra steps to set up things. As in just an extra note, the servers will remain up through the end of today. We will shut them down at 5 p.m. when we wrap up for the day. So please feel free to continue to use it if you want during the break or in between the other sessions, but we do have to shut down the servers at the end of the day. So. So the -r means recursive. You use it to make copies of directories. So the question on Slido was, what does the -r mean in CP -r? And that's basically telling it, I want to copy this entire directory and everything within it. Okay, so I'll just give one final thing here. Hopefully everybody's had a chance to either get the link to the survey or view it. I'm going to switch over to walking through the solution for anyone who's still here and would like to see how it was done. And after that, we'll wrap up and have our break for lunch before our next session starts at 1 p.m. So this is my solution to my short little exercise that we had to finish up the course. And what I do in it is first, I just add a comment. You can add any number of comments anywhere. It was just an example of here's how to add a comment. And then I want to export script version equals 1.0. And this is just, a simple variable that I can print out later and say, hey, this was my script version. If I make edits to it, maybe I'd want to change the script version as I expand upon it. And it's just a way so that the output is, we know what it was done with which version. After that, I'm going to do ls minus L and tell it everything that is in project summer ex3 files, take that out list of everything, and then I'm going to redirect it and tell it, print it. Actually, instead of the screen, print it into my home directory with example file list or example3 file list.txt. And that just makes that whole list of files from the directory. Then I go through and I say, I'm going to copy -r that whole list of files and put it into my home directory. And finally, I'm going to do tar czf, so create, zip it, and give it a file name, and make it my final example .tar.gzip. And I want to combine both that file list and all of those files that I placed into my home directory. I'll then search through all of those files in my home directory and list everything that has the user execute permission. And then finally, I'll print out my script version and then the word done. So since it's all set up here, I can actually just call it and run it. I do final exercise, and it says, okay, here's a list of all of the files that have a user execute permission. All the other stuff there, like the tar command and such, don't have any text output other than telling me that it's removing that leading slash. And then it prints out my script version 1.0 and then done. So it basically did everything within that script and ran it line by line as it worked through it. So I'll stick around for any other questions for a little bit. But yes, thank you for attending the session, and I hope you have a great rest of the day.